15 students. We wait on a little bit longer. Charlio, ¿cómo está?
Bien, bien. Good, professor. And you?
Muy bien.
That's good.
Liz, you know Tavalish? Tavalish? What?
Tavarish?
Yeah.
Oh, dog. Comrade?
Yeah.
Have to know that one.
Спасибо.
Spasibo.
You know that one.
Yep.
Yeah. Hi, Tim.
Привет, как дела?
What is it?
Hi, how are you?
Good. Good. All right, Augustino. Okay, so we can get started. We're gonna talk about a couple more design patterns, and then we're going to finish it. Then next week we can start something different. Maybe we'll do databases next time, or we'll do multi-threading. So let's get on to it. The first design pattern we're going to talk about today is called a composite design pattern. Okay, composite. It sets a whole slash part relationship. Okay, so you can treat different objects to behave same way, to as a whole, in other words. So it's hard to understand what that means. So I'm gonna go show you some very simple example. Then I will show you a very simple example. Then we're gonna do a more complicated example, and I think you may like it. Let me just start with a very simple example. By the way, I uploaded the code, so if you want, look at the code from GitHub, you can look at it. I uploaded last time. I think it was Monday. All right. So the first example I want to show you is under other design patterns. Okay. So the first example I want to show you is um, this composite design pattern. Now, what happened is, say you have a point of sales. That point of sales means you have, say, a store or library that sell different things. So in this case, say there's a grocery store or whatever, they sell tickets, okay, like play tickets or sport event tickets. And then there's another merchandise they sell is wine, say. Now, they are very different, right? The very different type of class. So one's a ticket, one is wine. Okay, so if you look at the instance variables, the ticket has the name, the number, and the date. Okay, whatever date that the sporting event or some kind of show event is.
I have to show you screen.
Oh, sorry, my bad. Keep on forgetting it. Actually, I cannot show there. I want to show here. Yeah. There you go. Okay. So now hopefully you can see it, right? So you can see there's a ticket class, and then it's going to be used to create a ticket objects. Okay. So then it also sells wine. Wine has a producer and vintage and the alcohol amount by volume. Okay, so and the price. So this is the constructor for the wine, and this is a constructor for the ticket. Okay, and then each of them has a method called a print. So you can print this ticket certain way. In this case, you print a name and print out the number and print out the date. Okay, so that's very straightforward. The wine as well, you will print out the producer and also the alcohol amount by volume and at this price. So that's simple enough for um, both of them. Now, what if you want to generate a invoice? Okay, you want to generate the invoice, and the invoice meaning people ordered both ticket and wine, even though they're very different. And then you want to print out invoice. In other words, you need a data structure that will hold both. Okay, so as people order stuff, this is like a shopping cart, right? So they pick the wine, they pick the ticket, so they all go into the shopping cart. So you need a data structure that will hold these two things. The two things are very different. Okay, there's no inheritance. They're not even related. The attributes are very different. You can see, right? So composite design pattern will say, okay, the solution is create an interface. Okay, so interface is called I item. I means interface, then item, so it's a general item. Okay, and the interface has a method just called print. You just print. Okay, so if that's not implemented, all right, so that is the glue. The interface becomes the glue to group the ticket and wine. Okay, now when you actually do the ticket, you're going to implement I item, and obviously then you need that print method, right? And when you do the wine, you also implement the I item, and then you also implement the print. Okay, now you need a data structure, right? Now here's the data structure. I just use array list. It could be anything, could be tree set, tree map, whatever. But the point is, now everything, both ticket and wine, are type of I item. Okay, because of that. So now you can have an array list in this case. The data type you can put into array list is I item. Okay, because I item is the interface. So that means you can now put both wine and a ticket, like a show ticket, into the same array list, into the same data structure. So it was different things. One's wine, one's ticket, right? They are not related in any way. But now by building an interface, you're able to glue them together and then make them the same type of object, which is I item type. And now because of that, you can have a one data structure that will allow you to add, add item. You see the add item. So you don't specify add wine or add a ticket. Instead, you can add item, okay, type, because that could be wine, could be a ticket, because it's broad, right? So you can add to the list, and then you can print all the items, and this just go cycle through the array list. You print every one of them, because every concrete object has a print method. So you just get that object out, whatever it is. It could be wine, could be ticket, could be whatever, you know, in the store. And each one has a print method, so you can print them. And then you can format all the print method in such a way, so when you print this, it becomes invoice. Okay, even though you have different things, but you print them in certain ways that look, they have the same format, then become an invoice. Okay, so so that's how you use a interface, using an interface that will allow you to group, you know, seemingly very different things, different objects, ticket and wine. Okay, so then the data structure is going to hold both. So now if you want to do this for a grocery store, for example, then you could make every single thing you sell to implement item and have a method called print. And the print method will format the data in a way that you can you want to show on the invoice. Okay, so that's the container that holds the list, holds different, seemingly different things now. Okay, now let's look at a demo. So I create a ticket, right? There's a name, and then the name who to purchase the ticket, and the number, whatever the number is, maybe the seat number or whatever. And then there's a date, okay? And then here you have a wine, and that's the wine, the vineyard. And then this is a vintage. And then this alcohol amount 15%. And then this is the price. So you make a wine, you make a ticket, they have nothing in common, you can see. Okay, now nevertheless, you can add them, you can create an item list, which is array list, remember? Now you can add items, so you can add the ticket, you can add a wine, no problem. And then you just cycle through, print every single item. So I have a method called print all items. So when you run the program, and then you will produce the printout for both items, see? So you can format it in a certain way that will look like an invoice, right? So when you go to grocery store, you pick up all different kinds of things, but when you check out, they're gonna have to generate the invoice, right? So this allow you to govern what you want to print it out on the invoice. Okay, even though they are very different things. So that is a very simple example of composite design pattern. So different things, different parts. Now by using an interface, you group them together into one type of object. Okay, like a item. So item in this case shows you the benefit again of using interface, or the importance of interface. Okay, that's the only thing they have to do just by implementing the interface. There's no superclass. So none of them needs to inherit anything from a superclass. This could be nothing in common. Wine, ticket, could be nothing in common. But since there's no superclass, so you don't have to worry about getting something you don't want. All you care is they belong to the same type of object, in this case, item, and all have a behavior like a print. And the print will format the printout in a certain way that will fit your invoice machine or the invoice. Okay, of course you can get the cost. So this way you can, when you do the printout, you also can print out the total price or the tax amount. Okay, so that's a very simple example. Do you have any questions here? Very simple. You just use an interface like a glue. okay, to allow you to have let me see what it is, to group things, very different things together. I think, let me see what's my, okay, so that's one simple example. You may need this all the time when you have something seemingly very different, but you want to put them into the same data structure, right? What are you going to do? So make them implement an interface. The interface may not have anything. This interface has a print method, right? But you don't even need that. Interface could be totally empty. Okay, interface could be nothing. But the sole purpose is not inject any methods, instead just to glue things together. Okay, so could be, and the good example would be like serializable. You know, if you ever save files into hard drive, there's a serializable you implement, and that interface is empty. There's nothing in there. There's no methods you have to implement. Okay, it's just there to indicate, you know, so the message sent to the class that the object needs to be serialized. So in this case, I do want some common behavior that is the print. Okay, so wine will print in this way on the invoice, will list this, and the price, and then the ticket will list in another way. So I didn't have a price, but it could have a price. All right, so that's one example. Okay, any questions on this? Very simple, but very useful. Okay, all right. So the second example is harder. I think I will just write it out for you, and so we're going to analyze this problem, which I have the code already, but I'm going to do P5 composite 3. Okay, P5 composite 3. So that's the new example. This example is a little bit harder to follow, but you will see the benefit of using it. Okay, so if we want to describe a group of projects again, a group of project of different, in this case, I use ducks. Okay, group different ducks. The different species, have different behavior, and so on and so forth, right? So obviously, what you can do is you can have an interface, like normally we would do, right? And we create an interface like we're gonna say dog, just say dog behavior, or just to indicate that is an interface, I say duckable. Okay, so whatever ducks can do, this interface will make you to do it, right? So so now you can have a fly behavior. Okay, so you have a fly behavior. So you can say void fly, right? So that's one behavior. And then you can also have a swim behavior. Okay, so because ducks swim, and then you also have another one is quack behavior. Okay, so that's a very common solution, because I'm gonna describe all kinds of dogs, right? So I might as well have a interface that requires the 3 different kinds of behavior. Okay, now when we actually do concrete classes, all we have to do is just implement this interface, right? So I will go to create a class. Okay, and this class, I'm gonna call this class I think I call it Malard Dog. Let me see. Okay, so I'm just gonna call this lard duck. Okay, that's like a green head. duck, very common on Long Island, Malala duck. Okay, so this kind of duck, you just say, okay, implements duckable. Okay, very common, right? And now that means you're gonna have to implement all these three methods. So all the three methods you have to implement it. So you're gonna say, so you would say sys out. Okay, you would say out. You would say lard duck flies. Okay, so you can do that, and then swims. So they can swim as well. So you can do say swims. Okay, then they crack as well, right? So you can say cracks. Okay, so that's good, right? That's good. So now you can have a demo, and you can actually create a Malala doc object. So you can say, okay, you can say Malala duck. Okay, so you say Malala duck equals new Malala duck, right? So that's the Malala duck. Okay, so now you can just do whatever the behavior. There's a D there missed. Duck dot fly. Okay, you can fly, and then you can do swim and quack. So that's not a problem. So that's the first step. That is a problem, right? Swim, swim, and quack. Okay, so now you can run this demo, and it does what it's supposed to do. Malala duck flies, swims, quacks, right? Okay, that's very good. Now, what if you have a different duck this time? Okay, so we're gonna have to create a different duck, and this time we're gonna call this rubber ducky. Okay, so I'm gonna say rubber ducky. Okay, and then you're gonna do the same, because you're gonna say that's the interface we have to implement, right? Duckable. Right. So when we do duckable, then obviously we're gonna have to implement those three methods. Okay. All right. So first of all, rubber duckies cannot fly. Okay. So, but you have no choice, right? You have no choice, and then you probably have to say something stupid here. You have to say why I'm having this problem. Then you say rubber ducky can't fly, right? Okay, but that's stupid because you don't even want the rubber ducky to have that fly behavior. Okay, no matter what you say here, it's not appropriate. You should not let rubber ducky fly. They can't fly, right? Swim may be okay in the bathtub, so you can do this. Okay, so rubber ducky swims. Okay, and then quack. Okay, if you want to squeeze it, maybe you crack, but not the kind of crack you expect. So we'll squeak. Only squeak. 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 Where's the space squeak? I think that's is that right? Squeak. Squeaks can only, it doesn't really crack, right? When you squeeze the rubber ducky. Okay, which is fine, some kind of behavior. But the only thing that is bothersome is rubber ducky should not fly. Okay, but you have no choice. You have to implement it because you implement the duckable, right? So now when you do the demo, you can create a rubber ducky, okay, and then you can call rubber ducky and equal to new rubber ducky, okay, and then you say rubber ducky dot fly, okay. So that's the problem, okay. Rubber ducky is not supposed to have that method, but we have no choice. So that's our problem. So this first step is not a good solution, right? Rubber ducky dot swim is okay. Swim, okay, and I spelled rubber ducky wrong. Okay, so finally, just the quack is okay. Okay, so you don't really, it doesn't really quack, so it squeaks. Okay, so there you go. So when you run this, and of course, you will say the rubber ducky cannot fly. But my point is, you should not even have this. Okay, it's just like rubber ducky cannot eat, cannot walk, things the rubber ducky doesn't have. You should not provide a method for it. But we had no choice because the way we did it is the most primitive way, so to speak. And that's what we learned in 148. We have a interface. And because of the contract, we are forced to implement all the methods. Okay, so that's the first step, right? So we say, okay, this is not great. Let's do it differently. So let me try a different step. So I'm going to rename this for the moment. So this way we can separate different solutions, okay? So here I'm going to say that's the first solution, all right? And now I'm going to do the second solution, P5 composite 3, 2. So I'm going to have a second solution, P5 composite 3, 2. So that's our second step, okay? Now I'm going to close this. So this way we're not P5 composite 3-2. Okay, good. Okay, now this time I'm not going to write just one interface. Okay, instead I'm going to have many different interfaces. So each interface just has one method to implement. Okay, so we can go create a interface. Okay, the interface, instead of a dockable, that's too general. Okay, so we're going to say flyable. Okay, so we have an interface called flyable. And the flyable, just say void fly. Okay, void fly. And then similarly, you're going to separate all that. You're going to have a second interface called swimmable. So suppose that's spelled right. So then you just have to say void swim. Okay, and then the third one would be crackable. Okay, that's another interface. So we say crackable, and then we're going to say this is just void crack. All right, so now we have three interfaces. Then we could just implement those two different docs. So one again is Malar doc, and Malar doc will only implement all the three interfaces. So implement flyable, implement swimmable, implement crackable. See, because it has all three behavior, right? Can fly, can swim, can crack. So now you can add all implement methods, and then you can just copy the three we just had before. Okay, so that is this. So I'm going to copy all the three, and then we put it into this place. Right, so now that's fine, right? So for this one is okay. Now let me do the rubber ducky this time. Okay, you can already see that now I have the flexibility to separate it now. So I have rubber ducky. Okay, now the rubber ducky, I know it cannot fly. So what you do is just don't implement that interface. So implement, don't do fly, just say swimmable. And do the crackable. If you believe it can crack, then that's fine. So now you can just implement those two methods. Crackable. My bad. Let me get rid of this. Okay. Now I'm going to implement both. Okay. So now you can just say sys out. You're going to say rubber ducky. Rubber ducky cracks. Okay. And then here you can say rubber ducky swims. Rubber ducky swims. Okay, so now I don't have that problem anymore. Rubber ducky cannot fly, so I don't implement that fly interface. So I just needed to go to do the demo. So I'm going to copy the demo over. Okay, just give it to this new package. Paste over here, save everything. So that's my demo. And and now you see, you don't need to implement the fly. So you don't have the method. So just get rid of it. Now it's fine. Okay, so this is a better solution to the problem. Okay, so you separate all the different behavior into different interfaces. And because Java allows you to implement more than one interface, okay, see, you can implement 3 of those, then it gives you the opportunity to create a different behavior for different concrete classes. Okay, and now you cannot do this for superclass, right? Because you can only have one superclass, right? You cannot have more than one. So that's again another reason if we can avoid superclass by using interface, we should use interface rather than superclass. Okay, because if you do it in the superclass, it's just like one interface, like the first solution, right? Everything has to be implemented. By having interface, you can separate them. Okay, does that make sense? Okay, that's the second step, right? The second step is fine. But the problem with that is, okay, let me close all this, and then I will show you the potential problem. Okay, this is fine, right? This is fine. Okay, you fly, the mother duck flies and swim and quack, so on and so forth. Okay, now if you look at the mother duck, right? If you fly, if it's look at mother duck's fly behavior, it just say flies. It doesn't really say how it flies. Okay, because potentially you can fly different ways. Okay, like a low level by the water, or it can be high, and then swims can be different as well, and quacks can be different as well. So you cannot really have different type of fly, different type of swim, different type of quack. The most important thing is those things. Once you code it here, you cannot change anymore. Say you could fly whatever way you want, you color coded here, okay, then you are committed to that way of flying. You cannot have you do not have the flexibility to change how it flies, how it swims, how it quacks in demo. when you actually use this class. So once you finish the class is committed. Okay, you cannot change anymore because of the closed, open close the principle, right? But what if you need different ways, different variations of fly, different variations of swim and a quack? Okay, you don't have the flexibility to change it anymore unless you change the source code. But you don't want to change the source code. You don't want to go to monolith duck class to change how it flies, change how it swims. Okay, because each one monolith duck may fly differently, may display differently, may swim differently or quack differently. So, but you don't have the flexibility. Okay, either you have it or you don't have it. If you have it, that's the only way to have it because you hard coded in here in the class. So you take away all the flexibilities. You cannot just go to demo, say, I want to fly this way. I want to, for this Maladoc 1, I fly this way. Maladoc 2, I will fly a different way. Or have swim differently or quack differently. So they all have the same behavior as long as they are Maladoc. Okay. And if you want to change behavior, you have to go back to the source code to change this, which is against our open close principle. So now we're going to take another stab at this. Okay, another way of doing this, and that is a composite design pattern. Okay, that gives you the chance to change your behavior while using the method. So the method is so flexible. The fly method can be changed any way you want. And also, you can add a new behavior without changing the original source code. Okay, so you can add a new fly behavior. Okay, so let's take a look at that. Okay, let's take a look at that. So let me close all this, and let's do that. Okay, the way to do this is very interesting. So I'm going to create a new package for it. I'm going to call this a P5 composite 3 and 3. So that's the same problem, and the third is the solution. Okay, and so those two are not composite. The previous two are just the regular traditional traditional solution. This is the composite design pattern. Okay, now here's what you do. You're going to create a superclass. Okay, you're going to create a superclass, which is called duck. Okay, you can even make it an abstract. Okay, make it abstract. And now this has is composite. So you can see it has a private, you have fly behavior. So you're not going to specify how you're going to fly. You just use a type of fly behavior. Okay, so then you can say fly behavior. Okay, and then you also have a private quack behavior. Okay, so you're gonna call that quack behavior. Okay, these two things, these are two data types. Okay, you do not want to commit how they fly, how they quack too early. So instead, these two are going to be interfaces too. Okay, just like we have I item before, we don't want to commit too early. So we just want something we can glue things together. So the fly behavior will glue all the different kind of fly behavior. Okay, so we're going to create a fly behavior interface. You'll see. Okay, so this interface, we just go fly behavior, and then here we're just going to have void fly. See, you're not committing it. You're not saying how you want to fly. All you want to saying is it has a fly behavior. In other words, you can fly. Okay, you can fly. Now you also going to go back to duck. Okay, let me save this. And then you can create a crack behavior. Okay, create an interface crack behavior. And then here you're going to just have a method called void crack. Again, you're not going to commit. You just say, I need such a behavior. Okay, so now once you have this, you can have two instance variables potentially have fly differently. You will see. You will see, because this is so general right now, is the fly is an interface. So the exactly how you fly can be determined later, can be implemented later. Okay, that's the point. All right, so you will see how interesting this is. So now I'm going to say public void set fly behavior. See, I'm not going to say how you're going to fly, but I allow you to set a fly behavior. And set a fly behavior, all you want is fly behavior, which is interface fly behavior. See, is that type of object without saying what this is. So this dot fly behavior equals fly behavior. Okay, fly behavior, that's spelled wrong. Fly behavior, fly BIOR.
I think you don't need the two parentheses.
Where?
Like in
So set
the
fly behavior, fly behavior. This
this
fly behavior.
the two parentheses at the end in line 8.
Jesus. Yeah. So now you set behavior. Again, it's very loose. You don't even know what a fly behavior is. You purposefully leave this open. Okay, you just set behavior. So behavior can be anything later. Okay, that's the whole purpose. So similarly, we do set crack behavior. Okay, so this is going to be a crack behavior. Again, this is an interface. That means it's not implemented yet. It's very open. Okay, so it's very open. Now, what you can do is once you have the two behavior, and you can implement. You can say how they how you want this method. So public void perform fly. Okay, perform fly, and then you can say the fly behavior. Right? Fly behavior, you know that the type of object has a method called fly, because that's what we declared earlier, right? You know that fly behavior has a method called fly, so it doesn't matter what kind of a fly behavior, it all flies. So I can do that, okay? And similarly, I can say public void crack perform crack. And then you just say crack behavior and dot crack. That's because also crack behavior has a method is crack. You see, so this is perfectly fine. That's perfectly fine. Okay, good. So that's the superclass, and it's abstract, and then that allows you to set. Okay, don't forget these are all public. That means all the subclasses will get these methods, right? They're not private. So subclass will get this method. All right, so now what we can do is we can actually define specific type ways of a fly if you want to. Okay, so what I can do is I can just create the first fly. What I'm going to say is right click, okay, go to new, go to concrete class now. Okay, I'm going to say fly no way. Fly no way. Okay, this doesn't fly basically. And then you say finish. That's a concrete class. Now you say implement fly behavior. Okay, implement fly behavior. So that means you're going to have to implement that fly method. Okay, so implement method. Then you can say cannot fly. Sys out. Okay, you just say can't fly. So that's one type of behavior that related to fly. Okay, so let me save this, and then I can do another fly behavior. So which is a concrete also. I'm going to call this fly with wings. Okay, fly with wings, and then you're going to say implement fly behavior. Okay, so fly behavior, then you're going to add the implement method. Now this time because I say sys out fly with wings. Okay, so there are two different ways of flying. One is not flying, fly no way. Another one fly with wings. Okay. All right. So similarly, I can have the concrete crack. Okay, so you can say right click, new, you go to class. So this time I just do a regular crack. Okay, so crack, I'm going to say, so these are concrete classes. Implement crack behavior. All right, so I just have to have that crack, and what I'm saying is sys out crack, crack, crack. Okay, so that's a crack behavior. And then there is another one called crack no way. Okay, so new class, I can say crack no way. Okay, so finish. And then we're going to implement crack behavior. Okay. So here is crack. So it doesn't really crack. We just say sys out. We just say no crack. Okay, and do nothing. Okay, so that's another another concrete class. And then finally, I just have another crack. I think is squeak. So right click, new class. I'm going to call this crack squeak. Squeak. Yeah. So crack squeak. Let me put a capital S here. Finish. Then I'm going to say implement crack behavior. Right. So and again, just implement the method and just go to sys out, and then you're going to say this squeak, squeak, and squeak. Okay. So so there are three ways of crack, and then two ways of a fly. Okay, so you see, in terms of concrete classes, right? So the three, there's a crack no way, crack quick, crack. So those are three different ways of crack. Okay, in terms of fly, you have fly no way, fly with wings. Okay, now both fly no way or fly with wings is a subclass of a fly behavior. You can see because both implements fly behavior. right? And then the quack implements quack behavior, quack no way implements quack behavior, and quack squeak implements quack behavior. So now those two methods, set quack behavior, set fly behavior, can be used to change behavior now. Right, to allow you to have a different way to fly and different way to quack. So now let's create the actual duck. Okay, so let's do the same thing. We could mallard duck, right? Mallard duck, and then we are going to just say extends, because I need those two methods: set behavior, fly behavior, set the quack behavior, right? Extends duck. Okay, so that becomes a subclass for the duck superclass. All right, so because of that, so we can now create a mallard duck. So public mallard duck. Okay, now the mallard duck, we can just set the behavior if you want. So we can say set fly behavior. Okay, then we can decide how we want to fly. So see, new, that's a default way of fly for a mallard duck. New fly with wings. See, that's a default fly behavior for mallard duck. And then you set quack behavior. And then now you can decide what's the default quack behavior you want. You just do a regular new quack. Okay, because fly behavior, fly with wings is a subclass of the fly behavior, and that's why it is allowed to do it because of polymorphism. Okay, because all you need in set fly behavior is a fly behavior, and because of polymorphism, fly with wings is a type of fly behavior. Okay, and quack is a type of quack behavior. So this is perfectly fine. Okay, that's perfectly fine, right? Okay, now we can actually create such a object. So that's our that's that's our concrete class. Now let me go to the demo. So let me create a demo. And demo, I'm going to create such a mallard duck, right? Mallard duck. So I'm going to say mallard duck. Okay, equals new mallard duck. Okay, so now you have a mallard duck. Now all you have to do is you get those methods for free from the super class. Okay, and so you have mallard duck dot perform fly. Okay, see, whatever behavior you get from perform fly, that matches the way the default way of flying, which is here, fly with wings. Okay, see. Okay, so now you can run it and you will see fly with wings. Okay, now if you decide you want to fly differently, right? You don't want to fly with wings. You change your mind. You want to have a different type of fly. All you have to do is mallard duck dot set fly behavior. Okay, this time you can say new. Okay, fly no way. Okay, now you change the behavior. Okay, now you want to fly this way. You will just say mallard duck dot perform fly. Okay, now if you run it, it's going to be can't fly. See, you change the behavior, right? See, when you are using the object, when you're actually creating the object, you can now have the freedom to control what behavior you want with all the flexibility. Okay, so that's what they call on the fly. Okay, you have a behavior change on the fly. So that's like when you design a video game, a computer game. Some actor can have different behavior at different time, in real time change the behavior. So that's one of the benefits. Okay, now similarly, you can do the same thing. You can say, let me separate this. Okay, then I can have rubber ducky. Okay, so I have a rubber ducky, and I don't have rubber ducky, so I'm going to create a rubber ducky class rubber ducky, right? Rubber ducky, same thing, that extends duck. Okay, so because it extends duck, you get that the two methods. So from the super class. So we're gonna put it in here. Okay, so this is gonna be called rubber ducky. Okay, rubber ducky. Then fly behavior. So now, if you want, you can make the rubber ducky fly with the wings if you want to. See, the responsibility is all separated. Okay, the responsibility is totally separate. You can make the rubber ducky fly with the wings if you want, or you can say with no fly. Okay, so in this case, I can say, let me see what I did. I can say fly no way, right? So if I want to say fly no way, I would just say fly away. Fly no way. Okay, sorry. And then in terms of set of quack behavior, I just say quack squeak. See? So now the default behavior of a rubber ducky is it doesn't fly and it makes a creaking sound. All right. Okay. So now go back to demo. I can do the same thing. I can just say rubber ducky. Okay. So rubber ducky equals new rubber ducky. So that is the default behavior will be set in. Fly no way, quack squeak, right? So now I'm going to do rubber ducky dot perform fly. Okay, same method. And rubber ducky, and then rubber ducky dot perform quack. Okay, so from quack. So now I can run this. So you will say rubber ducky cannot fly, but it quicks this way. Okay. Now, if you want to change the rubber ducky behavior, you could, right? So you just say rubber ducky dot set, depending how you want to do it, right? You can set fly behavior on the fly. You can in your demo, okay, on the fly. So now you can say new fly with wings. So if you want that wings. Okay. Now, once you've done that, then you can perform fly, and you instantaneously you get that behavior. Okay. So instead of can't fly, will be fly with wings. You see? Now the behaviors change. So if all the responsibilities, all the different flies, all the different quack are separated from individual dogs, you can just have all the freedom to assign whatever you want and whatever combination you want. Okay, now the most important thing is the next. The most important thing is, what if there's a new flying behavior? if it introduced one like flying is like flying with the feet, you changed the story. Now ducks can fly with the feet, or some ducks can fly with the feet. You don't need to go back to change anything, because open close principle, right? You don't want to go back change anything. All you want to do is create a new concrete class. Look at that flexibility. Now I'm going to create a new concrete class, new class. I'm going to call this fly with feet. Okay, well, this is ridiculous, but I'm just saying it could be something different, right? And then fly with the feet, and then you say finish, and then you just say implement fly behavior, because so this way they can be grouped under that, right? So now you can just say this is out, fly with feet. Okay, see, you just add a class. You're not going to change anything that's existing, that already in existence. Instead, just add a new behavior. Now, all of a sudden, because of this, you can make anything fly with the feet. Okay, so I go back to my demo. Let me save all this. And then I can make the rubber ducky fly with the feet. Okay, because all you have to do is just to say this. Okay, let me sys out this. And I'm going to say paste over here. And then here is just say add a new behavior, fly with feet. And then fly again. See, you don't even have to change this. The same method, the behavior is different now. So when you have this in some other classes or some other methods, you don't have to change that code. It still perform fly, but the behavior is completely different now. So there's so little change. You just have to add a new behavior. You don't have to change anything. You don't have to change the duck class. You don't have to change any interfaces, nothing. So now when I run this, and you see, you fly with the feet. You see the flexibility? It allows you to add new stuff, add a new behavior without affecting existing methods, affecting existing classes. So whenever I have a new one, just add a new. See, add and fly with the feet. If you want to quack differently, you can add a new quack behavior. You do not have to go back and change this class. You don't have to change any fly behavior. Just create it. Adding is okay. Changing existing one is bad, because you may have a ripple effect. But adding new things is okay, because nobody had it before. So just create a new one to create a new behavior. That's okay. So this has a lot of usage. Imagine all the video games, right? When you have different levels, when you level up, usually you have a different behavior, right? You have a different combination of behavior. Now you can easily add, or when the players finish playing, right? You can upgrade your game. So you want to then pay the upgraded version that has more different like a behavior, different strategies. You can just ask them to download these kind of files. These are new files. Okay, there's a minimum change to the program. Okay, now you're already introducing new behavior. So now you have an upgraded version of your software that has in different higher levels you can play. So there's a lot of diverse use of this. So I thought it was interesting, and the composite design pattern. So make your program more scalable. So you scale to a larger, more complex version of it without affecting the existing older version. Okay, even though the older version still work, right? If you have different kind of dogs, they still work. But now you can create a new type of ducks with a new type of behavior. So that is this composite design pattern. Okay, so you have any questions? Any questions, Tim? Did I lose connection?
No, you're still good there for me.
Okay, you can see me?
Yeah.
Yeah. So that's composite. This is a lot more complicated than the first one with just like a ticket and wine. But the idea is the same. You use some interface to group behavior, group different type of objects, like glue them into a group. Good? I think today's internet connection is bad for some reason.
I think I can see you fine, better than before.
Really?
Yeah, you're all good on my end. You're good.
Okay.
Yeah, you're good.
Do you like this design pattern?
Of all of them, I think that this one is my favorite because of how flexible you can be. Like like the example you mentioned, like you can download for the user, download later, like an upgraded version of your program. That's very cool.
And there's a minimum change to the existing classes, right? Because everything is changed right here. You can add a couple of files, right? You can add like a fly with the feed, and then you just go to demo and change this, right? You add a class, change the demo class. You're ready to go, right? That gives you the flexibility, right? And also you separate all different behavior, fly and then crack or whatever. You can separate them, and you delay the implement, delay the concrete class to the in the end. See, you implement the crack behavior, but use a composite because crack behavior is an interface we define without saying the exact how you're gonna crack, because unimplemented is abstract initially. But because it's interface, you can use it to group objects. Whoever implements that interface belongs to the same type of object. So this allows you to set. So allow you to set the crack behavior. So the demo, the set behavior. Where's the set here? See, the set behavior to allow you to set it.
A quick
It's cool.
question.
Mhm.
But don't you, as a developer or person that created this program, want the set behave the ability to be able to set or the behavior of either Quack or Fly to be private, not in the demo, like behind the demo? Don't you want it like that?
Yeah, you could, of course, you could. Yeah, usually by button, right? When you have a game, you click the button, then the behavior gets changed to a different one. Yeah.
Okay.
So this is just a demonstration in the console, right? Or when you get to a certain level, you get a new behavior. When you play a video game, right? When you get a higher level, you get a new set of behavior. You can cause more damage. So it's pretty interesting. But you do realize this is just a smart way of using knowledge we learned before. There's nothing here is new, right? I mean, the interface concept is we learned before. All those ideas we learned before. Here you just put them together to solve a problem, right? To give you the flexibility to change behavior in real time on the fly. Okay, so all the design patterns are not introducing new knowledge. It's just using existing knowledge to provide solutions to common problems. So we finished learning all the knowledge in the Java language. At this level, it's just like use the different concepts in a more intelligent way, so to speak. Okay, we're done basically with the language. We're not introducing anything new. The interface, superclass, we all learned before. But when we were learning it in 148, we never had the time or opportunity to think about smart ways of taking advantage of them. People almost had trouble understanding why you want an interface, right? And people had trouble understanding why we have interface if we already have superclass. Superclass is easy to understand because you have inheritance. But the interface almost bring nothing because you bring methods you don't even implement. You still have to implement it in concrete class. So what's the point to have an interface? At that point in 148, we just talk about this is the agreement, this is the contract. Whoever implements interface has to implement those methods. But there's no real rationale why you want the interface to begin with, right? Why don't you just remember this requirement to have this method? Why you are forced to have an interface? You know, what's the real benefit of it? Now you can see interface is so much more useful, okay, than we did it in 148. 148, which teaches concept, but we never had this capability of appreciate, you know, what it can be done, what it can do for us, interface, what the interface can do for us. Right now, you can see this is a beautiful application of using interface to solve some practical problems and give us the benefit of flexibility. Somebody came in. We're about finished. Okay, so that is 2 examples of a composite design pattern. All right, so we're going to close all this unless you have questions. Otherwise, I'm going to close all this, and then I'm going to look at another design pattern, which is kind of easy, okay, but also interesting. It's called a facade design pattern. Facade, okay. Facade is a French word. I think it means storefront, like the front of the building. You know, so so look at this problem, right? We want to build a robot. Okay, so we want to build something. So we want to build a robot. But because of we use object-oriented programming, right? The robot is made of different components. Okay, like in this case, robot made of its body, and also it has its own color. Robot has a different armor, like we use different metal. Okay, so each of this is actually a class. Okay, so basically a robot object is made of a body object, made of a color object, and made of a metal object. Okay, you don't just build a robot. All right, it's called like a robot made of different components, and each one is a class of its own. Okay, like a college is made of instructors, made of students, made of books and classrooms, buildings, right? Same thing. So what we end up doing is we have a robot body. You see, that's a robot body class. And we don't even have in this case, I don't even have a constructor. So we use the default constructor, right? And then I do have a method called create a body that just prints out a body is created. Okay, so I use the default constructor to create a robot body. And then the robot color, I don't have a constructor even though I could, but all I have is a set color. And then you can give a color and then set the color. Your printable color is whatever color you want. Okay. And then similarly, you have a robot metal. Again, it doesn't have a constructor. We use the default one. And then we can set the metal. Okay, whatever metal you want, then we just say that's the metal used for the armor of the robot. Okay, now with the three different classes, we're going to make a robot. Okay, so what we do is we have the three instance variables, one for robot body, one for robot color, one for robot metal. And then we have the robot constructor. And robot constructor will use the default constructors for body, color, and the metal. So when you call robot, the constructor, you create all three objects. Okay, component objects. So the body is created, the color created, the metal it's created. Okay, now I have another method of the robot is called construct robot. Okay, when I construct a robot, I'm just going to bring some parameters. In this case, I bring the color, bring the metal. Okay, and the interesting thing is why it's called a facade is that construct a robot will construct all set three parameters, or set two parameters here. One's a color, one's a metal for different objects. Because the color is meant for robot color object. Metal is meant for robot metal object. So you can see when I say construct a robot, just say system.out.println, creation of the robot is starting, and then you will set the color to the color you want. That's a facade. So from outside point of view, from the outside, you can see all you do is using construct a robot. You create a robot, you say construct a robot. Then you set the color, set the metal. But internally, those two values are used for different objects. One used for the color object, robot color object. One used for robot metal object. And then you create a body, and then it's finished. So from the user point of view, it's so simple. He doesn't even know there are three components. That's called a facade. Because all you see is the front of it. The front of it is controlled robot, construct a robot. Construct robot. So I'm gonna save this now. I see the demo. See, the demo is you create a robot, then you construct a robot. Okay, and let me get rid of this one for now. So I can construct one robot. So you see the facade? You have no idea how many components are out there behind the scene. It's behind the facade, behind the front. So all you provide is the color and provide the metal. And then the robot will be created. In reality, what's behind the scene is you have three different objects. Okay, so when you run it, you will see creation of the robot starting color is white because you said white. and metal is silver because it was that body created, then whole robot creation is complete. Okay. Now, if you want a different robot, okay, you want to change certain properties, you just say construct a robot. You provide a different color, different metal, and the same robot will have a different look. You're going to be say this time is gold, color is gold, metal is gold. So all the complexity is behind. Okay, the complexity is you need 3 different objects, 3 different classes, 3 different constructors used. You don't even know that. You don't even see that because it's all behind the facade, behind the face. So for the user, it's very simple. You want to change the color, just change the color. Change the metal, change the metal. One method does it all. One method does it all. You don't even see the complexity. You don't know the 3 objects, 3 classes involved. That's a facade. That's very useful. Right? You just use one method will change the property of multiple objects. You see that? Very interesting. Very simple, but very interesting. It allows you to change from one set of behavior, one set of property to another one. You see? But it looks so simple. It looks so simple. Just one method. Looks like you're changing the robot, but it's actually changing the components of the robot. 3 different components of the robot, but you don't see that. From outside, you can only see change the robot. But behind the scene is more complicated than this. It's really made up of 3 components. That's facade. Facade means the front. They have a building, the front of the building is called a facade.
All of this is going to be on your GitHub, right?
This is already in GitHub.
Okay, perfect.
Yeah, I uploaded last Monday,
Okay.
2 days ago. Right. But the other one I did it twice because the composite 2, that's the same thing. So, but it's harder to understand. That's why I decided to write it for you in here in real time. So the code is the same. I just because the kind of convoluted, so I decided to actually write it for you rather than just show you the code.
Okay, perfect.
Mhm. So we're gonna have some of these things to put in the final exam. Okay, so those are a few interesting design patterns, and we have another one, and that one's called a strategy design pattern. Okay. Before we do that, do you have any question on the facade design pattern? No. Right. Probably you guys are doing this already, like a facade and those things, a composite, or you probably have been doing like a factory. You probably have been doing this in your 218 or in even 148, right? But now this way of doing things formally has a name. Okay, you might have figured out this is a good way, but you just this happens to be something people already naming it. This approach, this strategy already got a name. So if you mention this, oh, let's use a facade design pattern to do this, then everybody knows what you mean. Okay. Again, I just want to tell you this is a something we don't teach on a 200 level course. That's why this course sometimes is transferred into a 4-year school at the 300 level course or 400 level course, is called software engineering. Because engineering means you don't really learn anything new. You don't generate new knowledge. You just use the existing knowledge to build something in a smart way. Right? That's engineering as opposed to science. So this is exactly the same thing. You don't have new concept, new ideas. You just have new way of using the existing knowledge to solve a problem. Okay, so so a lot of schools won't even, when you transfer in, they may not even have a software engineering course. So then they will not even accept this credit. They just say, we don't have this course. But I think this course will expand your resume a lot, because now all those different concepts can be put onto resume. Okay, they are usually are higher level topics. They're not at a low level, like a 200 level. All right, so we still have 15 minutes. Let's take a look at the next design pattern. We call the strategy design pattern. Okay, strategy design pattern. Okay, what we need is, first of all, I have a interface again. I call the choice. Okay, I put an I in front of it because whenever you see the name, you know that's just the interface. So I choice. Okay. Now the I choice interface has one method that's not implemented. So set choice. Then you have two strings. So the two strings, string 1, string 2, and then those are used as the parameters for the method set choice. Okay. Now, what's the most important thing is the context. Okay. Now the context is a class. Is a class, and then you have I choice. Remember that the interface. Okay, as an instance variable. Okay, say my choice. Okay, and now you can set choice. Okay, you can set choice, and you can have a method called set choice. Okay, in this case, you can use either your own constructor, that's your own constructor, or you can use the default constructor, doesn't matter. If you use default constructor, then most likely you're going to use the set choice. Then you put a choice in here. So what is I choice? I choice is whatever implements the I choice interface. So whoever implement I choice, that object belongs to I choice type. So this allow you to have a choice. So the context allow you to set the choice. And the choice could be very different things. As long as they implement the I choice, see, then they are acceptable. See? So set a choice and you put an I choice in. And then you can also do things based on what happened. Okay, you can do it with another method. Do things based on choices made. So the two strings. Now is the my choice has a method called set choice. Then you can have those two strings used. Okay. So now, but the important thing is you still don't know what you're going to do with this two strings. Okay, so what are you going to do with the two things you don't know is defined in set choice, but set choice is not known yet. Okay, how are you going to set it? You don't know yet. So here it is. So I have my choice 1, implement I choice. So that's one strategy. Okay, so if you have one strategy called my choice 1, strategy 1, now because you implement I choice, so you have to use the method set choice, you have to override it, right? Then that needs two parameters. Then you say I'm doing things based on my choice 1. So that means you take the two strings and you do things based on my choice 1, the first strategy. Okay. Now similarly, we have the second strategy, which is also a different strategy, and you just say implement iChoice as well. So same method. Now you just say, yeah, doing things based on my choice 2. Now this time, these 2 strings are parsed into integers, and you add them together. Okay, so if they're possible, of course, then you parse that first string into integer, parse the second string into integer, you add them into another value. So it's not just concatenated. You actually turn them into numbers and add them together. But the first choice is you just simply concatenate them. Okay, so that's the 2 different strategies, right? So now I have my demo. Okay, so I have 2 strings. One is number 1 is 5. Another string is number 2 is 10. Okay, then I set up a scanner, and then I have my context. I use the default constructor. You see, default constructor, and then I allow people to set the choice 1 or 2. So I pick that 1 or 2. So if choice equals 1, that means that's the first choice. Then you get I choice equal my choice 1. That's the first strategy. Okay, if you pick the user enters the 2, then that means you're going to use my choice 2. That's the second strategy. Okay, so you have 2 strategies you can use, you can set, right? Now, the same context, you can set the choice, and then whatever choice you decide to have, 1 or 2, will be used as a set of choice. Then the context can do things based on choice made. Okay, so you can see context, do things based on the choice made. So which is my choice, set the choice, the two strings. So you can do this for my choice. So you can, let's run the program. Then maybe we'll come back for this. Okay, so we have 2 numbers, both are strings, and then we have a choice 1 or 2, and 1 means to concatenate them, 2 means to add them, parse them, then add them. Okay, so so enter your choice 1 or 2. So if I put a 1, then what I should get a 1 1 5 1 0. See, I just concatenate 5 and a 10. I can 5 and 1 0. I concatenate them 5. So if I do 2, that's my second strategy, right? Then I should get a 15, right? I'm doing things based on my choice 2. That's the second strategy. So that's why 15 is a 5 plus 10. Last time the 5 concatenated with a 10. All right. So this gives you the user a choice, what strategy you want, what kind of behavior you want doing the main method. You can decide. Okay, same data, 5 and 10, same data. You allow people to decide which one, how you want to process these 2 pieces of data, the same data, 2 different strategy. And depending on what choice you get, if it's 1, it's my choice 1. My choice 1 says just do this way, set the choice and do this way. Okay, my choice 2, set the choice, do the other way. Right, both is implement I choice. Because of that, both my choice 1, my choice 2 are a type of object of I choice. Okay, so you have the context, you just say I choice. See, you can bring an I choice, you can set the choice, then whatever choice you get, they're going to do things based on that. Well, of course, this is simple. You could have more methods based on the choice you want. So this is just one method. You can have more than one, many, based on the same choice. If you pick this, whatever choice you pick, okay, so that's going to be processed differently. That's again very useful You know, you can have a game and you can have a different strategy, different behavior during runtime. Okay, and you can add new choices too. Just add another class. If you want the third choice, just add another my choice, and you write the same way, right? So just implement an I choice, then instantaneously that new choice, my choice 3, becomes an object of the same type, of I choice type. Okay, and then the context will be the same. You see, the context is the same, and then all you need just to do in the demo. The demo will allow you to have 3 choices, 3 strategies. So again, this is similar to the to the one we did composite design pattern. This will allow you to change, add new strategies without affecting existing classes. You can add a new strategy, then use it in the main class just by setting a choice. That's all. To give it a choice. Just set the I choice to a different one. That's all. And then you can do things in the context. It's the same context, just have a different behavior depending on what strategy you want. Very interesting, right? Very interesting. And then there's a bunch of other strategies. Strategy 2, maybe I can give you another example. Here is the strategy interface. It's a strategy interface, a set a strategy. Okay, and then we have actual 2 strategies. The strategy interface. So set strategy. This is strategy 1, and then this is strategy 2, and then I have a context. Context allow you set a strategy. Once strategy chosen is set, then you can perform the chosen strategy. It's very similar to the composite. So you can set the strategy, and now you can do demo. You can strategy 1, strategy 2 with the context, then set strategy 2 as strategy. You perform the chosen strategy. You see, this is very neat. So you can just do run and say this is strategy 2. And if you want to do 1, you can just do 1, set strategy 1, then the whole strategy gets changed. You do it in the main, in real time. When you actually run, the key word here is this allow you to allows to change strategy during runtime, not design time. When the program is running, in the middle of running, you can change the strategy. You can change the behavior during runtime, because main is the only program that's executed during the runtime. Okay, because that's where Java starts with the main method, right? So this allows you to change strategy during runtime. Okay, you can add a new strategy, no problem. Just add another strategy. Of course, you can do very different things, and not just simply saying this is strategy 2 or strategy 1. Okay, all right. I think there's another one that is very similar. I have an ability that is interface, but this time it has 3 methods unimplemented: travel, handle weapons, protect, right? So there's 3 methods unimplemented. And now I have level 1 that implements ability. So there's 3 methods are implemented this time. Okay, travel means travel on bike. That's level 1. Handle weapons, fight with a knife. Then protect is wear a sweater. That's not protection. And then level 2, you still implement the same ability. Then travel means now on foot and fight with bare hands. That's very low level. And protect, wear a t-shirt. And level 3 is a higher level, I guess. Travel on tank and fight with a 0.28, wear a body armor. So now here's the context, allow you to switch. So you set ability, you provide the ability in, and then you can do all 3 things based on the ability. See, whatever ability you set, you will do accordingly. Travel, handle weapons, protect accordingly. And you can combine all 3 behaviors into one method called act, which include travel, include weapon, handle weapons, include protect. Okay, now look at the demo. Demo, I have 3 levels, like a game. You have 3 levels of the same game. And then you have the context. Okay, you won't set the level 3, you just act. Then all 3 things will be incorporated. If you want to go to level 2, I just change this in one time. And then all things get changed in one shot. Okay, you go to level 1, right? So and then all 3 things gets changed. The entire behavior gets changed. So it's very cool. You can do this on the fly when you play the game. You know, you can change your behavior. Or as the game, you don't have to shut down and replay the game. The game can be in runtime. You click a button or you killed some enemy, reach some scores, then you can have a total different level, a new set of behavior with a new set of weapons, a new set of armor or lifelines. So this is used widely in video games. Okay, so that's called strategy. I think that's it. That's it. And oh, that's all the design pattern we're going to talk about. There are a lot of others, but these are the main common ones. But I guess you just have to know there's such a thing as design patterns. You know some common ones. That's it. Okay, down the road when you actually do professional work, then I'm sure you're going to encounter or you're going to learn more. Just kind of now, just get an idea. There's such kind of a thing called design patterns. You know, usually all the problems we see today are already solved in the past. There's already a design pattern. So we don't really need to reinvent the wheel, so to speak. All right, so that's it for the day. And I see you next week. And I'm going to give you a set of homework problems for design patterns, and then you can practice. All right? And also prepare for your final exam. Okay, otherwise your final exam will be off the rails. Okay? Now we have to put some rails on, so this way you can rely on. Okay? Good. Okay, so have a great weekend, and then I see you next week. Okay, adios.